So has everybody gotten that completed? I don't see all blue tabs up yet. Oh, you don't have a blue tab. Well, you weren't here when I started putting out tabs.
Yeah, it's also.
Okay, good. What's that? Yeah, whatever you've done to clean up, run whatever your full cleanup is. So for me, I checked my working directory. Um, I was working on this earlier today, so my working directory is correct. So I read in my data, I checked it, I ran structure on it. Then I also set things to factors, checked those to make sure that those are all as factors, and they are now. Then once again, this is my version of the analysis. Then after that, I wanted it to treat them in particular orders. So I did that, and then I checked that. So it's doing winter first, then summer, then Galveston, then Oklahoma City. I don't know why my mind thinks this way, but then I also changed the capitalization using factor recode because I want this to all be capitalized so I don't have to mess with it later on when I'm doing graphing and whatnot. And then I use table to check and make sure that in all of those machinations I didn't accidentally delete some data, so I can use table to tell me how many observations we have under each of these different categories. So you should have at this point a nicely clean and organized data set. So what I want to do today with you is take you through the initial steps of what you're going to do for your final report. So your final report, the assignment, did I reveal the assignment? Did I turn it on or did I forget to do that? Let me go find that. I think I was in the middle of doing this when I realized that I was late for class and needed to come down and or come up and be with you guys. So, oh, nope. So if on Moodle you go to this week's materials, you should see that there's a folder now for the linear regression report. So this not very smart biologist has come to you once again. You did an ANOVA for him where you compared, for example, body temperatures to wall temperatures, and you found that those didn't really differ from one another all that much. But he wants you to examine that relationship a little more deeply. So if you look at your data frame, so just call up the data frame. You can use head whatever your data frame is. What you will see is that your data file has season, temperature type, population, and then it has a column for temp, and it has a column for W. Temp is just whatever temperature it is, and so he rearranged this data set so that all temperatures are in that temp column, and the temperature type that it is specified by the type column. But if you look at the data file in its entirety, So let's view the entire data frame. You will see that where you have body temperatures, you also have another column with corresponding wall temperatures. And as soon as you get out of the body temperature category under the type column, you will see that there are no wall temperature data. So once you shift to environmental temperatures, because these environmental temperatures were just taken randomly along the wall, there are no corresponding wall temperatures. So remember that the wall temperature is the temperature of the wall right next to the gecko. So in theory, those two temperatures should be relatively close to one another if these lizards are not thermoregulating, if they're not regulating their body temperature. And so we have all these NAs because there are no corresponding wall temperatures. So this temperature is the body temperature of the lizard and then the wall temperature right next to the lizard. So what this person wants you to do is to examine this relationship more closely. If these lizards are truly thermoconforming, what you should expect to see is if you have wall temperatures from cold temperatures to warm temperatures and body temperatures from cold temperatures to warm temperatures. If these things truly are thermoconforming, they're not capable of moderating their body temperature, changing their body temperature. All they do is take on the temperature of the environment around them. What would you expect this relationship to be?
A perfectly straight line.
Yeah, you would expect it to be a straight line where the temperature at cold temperatures is the temperature of the body temperature. When the wall temperature is medium, the body temperature will be medium. And when the wall temperature is warm, the body temperature will be warm. If these things are thermoregulating, what would you expect this relationship to be? If they're capable of altering their body temperature in ways that set it at a particular temperature that is independent of their environmental temperature.
Either hotter or colder.
They would be either hotter or colder than the wall temperature, but they would be something different, and wall temperature wouldn't have any effect. So what would you expect the slope of this line to be? This is a slope that is positive. You would expect a slope of 0. This would be a thermoregulatory sort of response. This would be a thermoconforming sort of response. Now, do you expect this to be the same relationship whether you're in winter and summer and whether you're in Galveston or Edmond, Oklahoma? Probably not. Remember that in the winter in both those populations, the body temperatures and the air temperatures, all of the temperatures are considerably lower than the preferred temperatures. So you might expect this relationship to be such that geckos are trying to raise their body temperature during the winter. And in a similar way, the preferred temperatures in the summer are lower than the temperatures that they experience. So you might expect them to be trying to cool themselves off in the summer. So what the researcher wants you to do is he wants you to look at the relationship between wall temperature and body temperature for summertime in Galveston, winter in Galveston, summertime in Edmond, Oklahoma, and winter in Edmond, Oklahoma. So this would be 4 regressions testing whether or not these things tend to be thermoconforming or whether they tend to be thermoregulating. So you have a data file in here. How are you going to begin approaching this process? Are you interested in, yeah, go ahead.
Will you filter your data set for only body and wall temperatures?
Okay, so you don't need the wall temperatures in type because the wall temperatures are here. In order to do a regression, you have to have these in 2 different columns right next to one another so that this temperature is always correlated with this temperature.
How did you get that?
The researcher gave it to you this way.
So
So you would start by filtering by TB. So you would make a new data frame that is filtered. And the filtering would be, you've done this filtering before, right? What's the code for that? You're filtering the data frame, and then you're filtering the data frame by the type of temperature that you're interested in, and we put two equal signs because that's what equals means in R speak, and you are going to put in quotes the thing that you want it to filter. But let's do this. Let's change the new data frame. Let's make a new data frame so we can keep our original data frame intact. Let's call this new data frame DAT1 instead of just DAT. So do that to this data frame, and then run structure on it and see what it gave you. So I'm going to come down to the end of this. Yeah, at the end. I'm just going to do it up here because this is where I happen to be. And then when you've done that, get the structure, and what you should see is that you have filtered out all of the other temperature types, so you're left with 182 observations. So blue tabs up when you've got that done. Orange tabs up if you had a problem. Or are you taking your blue tab down? Are you having difficulties?
I don't.
No, you got 182. All right, everybody have this? All right, then blue tab's down. View this data file. Whoa. What's the problem with the data file at this point? For the purpose that we're doing right now. If the researcher wants us to look at each season and each population separately, will the data file in its current form work for us? What's happening on the screen right now? It's all body temperatures, but what else is there? Well, it does have wall temperatures as well, which we need the wall temperatures. But what else is happening? What do you mean, not everything together?
Or we're looking at both populations.
We're looking at both populations, aren't we? We have summer temperatures, but we have Galveston and Oklahoma City. And if you continue scrolling down in view, you will also see that we have winter temperatures for both Galveston and Oklahoma City. So all we've really done at this point is we've reduced this to just having body temperatures in the temp file, wall temperatures in the TW, body temperatures in the temp column, wall temperatures in the TW column, but we still have all combinations of summer, Oklahoma City, summer, Galveston, winter, Oklahoma City, winter, Galveston. Yeah. So you could, but what's a more elegant way of going about this? Well, you could facet it, yes, and we will facet eventually. That's how you're going to make your graphs for this, is you're going to work with the entire data set and you're going to facet that thing. But for now, what we want to do is we want to have 4 different regressions. So if we can filter by type, can we filter by other things? What else would we filter by? Okay. No, that's what we would do if we were doing it the rough and ready way. We could filter it once. Oh, let me go back and get my code. If we wanted to take a totally brute force approach to this, we could make DAT1 filtering DAT by body temperature. Then we could make DAT1 again by filtering by season. Then make it again filtering by population. But let's just see what it does when we do it all at once. So we're still going to go back to the original data file. So when we look at the structure of DAT, it's still 1,395 observations. So let's now just add these other levels of filtering. Now I've changed my summer and winter to be capitalized, so if you didn't do that, do not copy this down directly. And once you make this new data frame, get the structure of it. Oh, I did something wrong because I have no data. Why do I have no data? Oh, it's all caps. Thank you very much. Hopefully you have 52 lines of data now in your new frame. When you have 52 lines of data, put your blue tab up and then go and view DAT1 again. And when you view DAT1, scroll all the way down, and what you should see is you just have summer, Galveston, and then the 2 temperature types. Blue tabs up when you have it. Yeah. Okay, so you probably misspelled something. So if you didn't change the capitalization, then you don't have a capitalized summer in your data frame.
Do.
Oh, do you? Okay. Do the structure. Let me see structure of your data frame. Okay. All right, so we have, no you don't. You didn't do that. So just change your capitalization to lowercase s and it should do it. Now check it. Check the structure of it so you know how many data. Oh, you have 52. Okay. So there you go. That did it. Everybody else get that to work? Okay, is that one the most descriptive thing that we can call this? I like calling things descriptive things so that I know what they are. So I would probably save this as something like SG to stand for Summer Galveston, simply so I can keep it straight in my head. So I'm going to go and do that. So instead of DAT1, I am going to call it SG. So when I get the structure of SG, I want the structure of SG, not the structure of DAT1. Should be the same. Now, if you go over to your environment tab here, which we don't really look at very often, you will actually see that SG is now here, 52 observations with 5 variables, but you will also see that DAT1 is still here. So they're both still hanging out in in R, and that's fine, but just know that DAT1 is there and available to you. Now that you have a data frame that only has Summer Galveston data in it, what will you do now?
Wait, do we only want the summer Galveston?
For one of your regressions, but you also then want Summer Edmond, Oklahoma, Summer. Yeah, so what you need to have is you need to have 4 different data frames. A data frame that has Summer Galveston, Summer Edmond, Oklahoma, Winter Galveston, Winter Edmond, Oklahoma. You can all go back to the DAT, your original data frame, and pull these. That's why I didn't overwrite the original data frame when I did this, because I know that I'm going to be going back to that data frame to get other subsets of the data. So in this case, we would do the same thing. We would filter this thing. We still want just the body temperatures. We want season, but with population, we would change this to OKC. And that would be the Edmond, Oklahoma data. We would do the same thing again for this, filter that, body temperature, but in this case, we would want to do winter instead of summer, and we would want to do population equals Galveston again. And you would end up with 4 different data frames, and you would analyze each of these data frames separately. So you would have 4 regressions, so you're going to be reporting on 4 different regressions. You should expect the slope values to be different, you should expect the significant levels to be different, etc., etc. Remind me what the form is for running a regression in R. What's the form of the script code? What's that? Yep, it's a linear model. Of what on what? What's our response variable in this case? Response variables, yep, it would be body temperature, which is in the column temp, as it's determined by or as it's affected by wall temperature, which is in the column TW. And what's the data frame that we would use for this? Let's just start with SG. So we might want to call this something like SG reg or reg SG, regression on the Summer Galveston data. That would save this as a particular model name, and then you can get the output by either typing summary SG reg or by typing ANOVA SG reg. What's the difference between these 2 types of outputs in R? It isn't the means, because there are no means here. In regression, what are the things that we're interested in knowing?
R-squared value.
We're interested in knowing the R-square value. We're interested in knowing the y-intercept. We're interested in knowing the slope. This thing gives you the slope. It gives you the y-intercept. It gives you the R-square value. This gives you the ANOVA table that these things are based on.
Isn't it for the ANOVA table, you could just do summary .aov?
Yes, you could do that also. Yes, many paths. You could do this. You could do this. You could do this, and it will all give you the same thing. Welcome to the wonderful world of R. You would think you could type anything in and it'll give you something, except if you misspell a variable name. Then it will give you nothing. And you would do this for each of your different data frames. Now, once you have those data and they're all analyzed, you know what the answer to the question is. They're either going to be thermoconforming or they're going to be thermoregulating. and that'll depend upon whether or not the slope is positive or the slope is not significantly different from 0. How are you going to graph this? What would be your strategy for creating a graphic for these data?
Make 4 different plots, I guess.
Okay, so you could make 4 different plots. You've already subset your data, so you could just go to each of those subsets of data, make a plot for the summer Galveston, a plot for the summer Edmond, Oklahoma, a plot for the winter Galveston, and a plot for the winter Oklahoma data. What would that graph look like in terms of X and Y variables and whatnot?
All look the same.
Yeah, they would all look the same except you're using different data frames. And so what would be on the x-axis? Well, generally we're thinking of body temperature as being the response variable. So this would ultimately be the temp column, but you would rename it body temperature. Then what would be on the x-axis? Wall temperature. And you would want it to plot the line, right? And you would want it to put confidence intervals around that line, right? Do you guys remember what the code is for doing all of that? You don't? Why not? What are we going to use? What are we going to start with? ggplot. What's the first thing that ggplot needs to know? It needs to know what data frame you're going to be using, but in this case, doing it this way, are we going to use that? We're going to use one of our subsetted data frames, and then what do we have to give ggplot? We have to give it aesthetics, and in this case, what are the aesthetics that it needs? Somebody else. I'm tired of that table.
So, why are we doing
SG regression is the regression model. We are going to graph the regression model, but that is just the SG reg just gives you the output from running the model. You want to actually graph the raw data, and the raw data are in the data frame that you based SG reg on. So what are the aesthetics? X is going to be what? Wall temperature. And Y is going to be body temperature, which is in the column temp. And do we need anything else there? What have I forgotten to do that I always forget to do? Well, I could assign it something. SG graph. It's still not going to run because I've forgotten to do what? I haven't told it what to graph yet, but it'll run even without that graphing. As long as you give it a text, it'll just give you a frame with no data in it. But it won't even do that at this point because I've forgotten. I forgot my closed parentheses. Yeah, good. Thinking through that list of things to check when you get a line of code that won't run for you, I didn't close my parentheses. So now that I've closed my parentheses, what do I want to add to this plot? You want to add points, data points, and you can format those however you want. What else do I need to add? Geom smooth. But I have to tell it what kind of smoothing function I want it to put in there. What smoothing function do I want? And how do I designate it? Method equals linear model, because that's what we ran. We ran a linear model, not a Loess model, not any sort of quadratic model or anything else. We ran a simple linear model. Then we want to do things like all the formatting of everything. Whatever it is, changing the names of the axes, changing the size of the fonts, all that formatting stuff that you probably have a common formatting block for, plus all those little snippets of code where we basically say what the X label is, the Y label is, all that jazz. All that jazz you know how to fix already, but you know how to do all of that. No point in belaboring that point. This is what you need to give yourself a scatter plot that then has the best fit line and a 95% confidence interval around that best fit line.
And then you add the theme state as well. Right?
Yeah, that's what I mean. This is whatever all that is, plus the X label, the Y label, anything else you need to pretty this thing up and make it informative for somebody. But like I said, you guys know how to do that. You guys have done that before plenty of times. This is the part that you're less familiar with. Now you could do that for each of these things. You could have 4 different plots. If you name these 4 different plots, you can have names for each of them. Now you can present those each as 4 different figures, or you could put those all together in a single figure. There's a function in ggplot called multiplot. And what multiplot does is it basically allows you to put multiple plots into a single graphic. And so you could designate multiplot where you plot SG graph. You would then do SE graph for Edmond, Oklahoma. And I don't remember if you have to put these in quotes or not because it's been a while since I've used multiplot because I usually use facet. You can then do WG graph, and then you would do WE graph. And then once again, somewhere in here, you have to tell it that you want to put it in 2 columns and 2 rows. This is the approximate form, but like I said, you can look up the syntax for multigraph on the web, and what it will do is it will give you a graph that looks like this. It will have independent axes. It will have labels underneath each axis, et cetera, et cetera. But what's another way that we could do this? We could actually just facet it. We could set up a generalized plot where we do ggplot, where we use the original data frame, and we have it give us aesthetics. X equals the wall temperature, Y equals the body temperature, and then we can call that TB versus TW. That saves it as a graphing code, and then we can do TB versus TW plus facet grid, where we then separate those different subsets of the large data frame into separate graphs. And you could do this a variety of ways. You could facet grid where you are facet gridding with season and population, or you could facet grid with season and have populations, the 2 populations on the same graphic. So rather than having 4 graphics, you would have 2 graphics. One graphic would be for winter, one graphic would be for summer, and on each graphic you would have Edmond, Oklahoma and Galveston plotted next to one another, or on top of one another. Yeah, it would be 2 lines on the same graph. And so you can facet this way in any of a variety of different ways. You could actually facet by population and have the 2 seasons plotted in the same figure. You could plot by both of them and it will create these 4 graphs. What the advantage of that is that it puts labels at the tops and on the sides for what the faceting is. And the other thing is it doesn't take up space by repeating the numbering scale, 15 to 40, 15 to 40, TW, TW. It doesn't take up all that space, but if you do it individually, like this, what's going to happen to the x-axis and the y-axis on every one of those plots? It's going to have different values. And so if you want those figures to be comparable from one figure to another, what are you going to have to do? Yeah, you're going to have to go in and use ylim and xlim to tell R what the limits are on those things so that you can make those all the same, so that when you look at them as a group, they're all easily comparable to one another. What does faceting gain you? Put everything on a common scale so you don't have to worry about that. So if I was doing this, I would probably use faceting simply because it takes less coding, it's going to give you a cleaner output, and whether you facet it by one of the variables or the other variables doesn't really matter to me. Facet it however makes the most sense to you. But one of the nice things about faceting is it takes care of a lot of the labeling of what graph is what, and it also keeps things on a common axis dimensions so that things are more comparable from one figure to the next. So you could easily have 4 regressions that are all summarized in a single graphic that you then refer to the different portions of that single graphic as you're going through and describing what the results are.
So to do that, just to make sure I understand, you have to do the TV versus TW first.
Yeah. And what I would suggest to you is after you do this, look at it, and what you're going to see is a broad range of temperatures, and you're going to see a cluster for winter. You're going to see this. This is actually what it will look like. When you do this thing, just the TB versus TW, it's going to give you a graph that goes from like 10 degrees to 40 degrees centigrade. But what you're going to see is you're going to see a common line going through the data, but you're going to see 3 different clusters of points. You're going to see a cluster of points down here, which represents winter Oklahoma City. You're going to see a cluster of points here that represents winter Galveston, and you're going to see 2 clusters of points up here, which represent summer Galveston and summer Oklahoma City. So this thing that you do here is going to give you all of the data and run a single line through that data. Then you go and facet it, and what it does is it pulls those groups apart.
And on that, should that be an equal sign between two?
Oh, no, it shouldn't. It should be an assignment operator. What's that? Yeah, no, good. You're thinking through the code.
So we'll technically faceting this the same way as we did.
Could be.
Not the exact same.
But similar. Yeah, sure. Yeah.
So once we've made like the TV versus BTW, we have to add like our geom point, geom smooth.
Yeah. So yeah, all of this goes to that. I'm just changing the first line because that's the thing that changes. And the only thing that really is changing is, are you doing a subset of the data or are you doing the whole data? If you're doing the whole data, it'll look like that you then use faceting to pull it apart. If you're doing the subsets, it'll just give you one graph that is just that subset of the data.
If it were you, you'd facet.
I would, because it's so much easier and so much nicer. But you can do whatever you want. I will not count off for not faceting the data. It's just that you're going to have to either multi-plot it or you're going to have to present each of those datas as separate figures, which means you have to write 4 different figure captions. Yeah.
But before we can do that and like graph everything on the faucet, you still have to run a regression model over each
subset.
Each subset. So we still need to make the
Yep.
subsets.
Yeah, you still need to make the subsets, but so if you ran the regression model on the full data set, it would give you this line. But what you really want to know is you want to know what each of these relationships is. And just so you know, they end up being kind of like that. They end up being steeper in the winter they end up being more shallow in the summer and closer together in the summer, which should not surprise you guys at all at this point dealing with this data set. One of the reasons that I use this data set is not because I think you guys should be interested in gecko thermoregulation. One of the reasons that I use this data set for your reports is that it helps you get to know the data so that you can see when things aren't turning out the way they should as you're going through your analysis. One of the hardest problems that a data scientist has in doing his or her job is getting familiar enough with the data that you're dealing with that you can know when an analysis is going off the rails. Because the problem with using computers is you can get a computer to give you all kinds of garbage. As long as you tell it the right thing, it will give you anything. The question is it giving you the right thing? And so by returning to this data set over and over again, we're now analyzing these data with regression. But even within that, you should be able to tell whether or not R is giving you the right output. When you run the summary of whatever your regression model is, you should maybe expect the y-intercepts here to be lower than the y-intercepts up here if these things are actually having a shallower slope. You should expect slopes to be maybe shallower here and slopes to be steeper here, once again, depending on what the data look like when you look at them. So once again, use your knowledge of statistics to think about what the output is that the computer is giving you and how that output should look. Questions? Yeah.
So then in our report, will we have 4 different figure captions for the, like, I guess the ANOVA table of each regression model?
Once again, I could probably design a table that would efficiently cover the regression results from all 4 regressions in a single table. So what's that?
That's probably right. Because I guess all we need from that is R squared slope y-intercept.
R squared slope y-intercept, what else?
P-value?
F statistic, degrees of freedom, and p-value would all be nice also. But you could do that for each subset of your data. You could put all of those things in a single line in a simple table so that the reader would be able to access all of that information all at once. And so what you could do then as a reader is you could look down that table and say, oh, well, what are all the slopes? Oh, it looks like the slopes are steeper in the winter than they are in the summer. It looks like the regressions are significant in the winter and not as significant or not significant at all during the summer. So by having it in one table, you actually do your reader a favor, the recipient of the data a favor, because it allows them to just go down the column and compare the different subsets of the data. You could put it in 4 tables. It's just not as helpful to the recipient. Plus, it would be a table with 2 lines. One line telling you what all the columns are, another line telling you what the season and the population is, and then one line of output, which seems like a waste of space, because you could still do the same top line telling you what everything is, and then do each subset in 4 lines, and then just be more efficient about it. Always be thinking of ways of making life easier on the recipient of the analysis. This person has come to you for help. Have you already done it? Have you already done it? Oh yeah, see, you're doing that rather than listening to me yammer on about stuff. Yeah, you've got. So this is Galveston and Oklahoma City versus summer versus winter, and you can see that these 2 things are close to one another. Once you get, project that on the screen, bump me off. Since you're not paying attention anyway, I might as well use that. So she's done the faceting while we've been sitting here. It's not the prettiest graph because she hasn't done anything with themes and whatnot. Here you can see Galveston is in this column, Oklahoma City is in this column. We have summer here and we have winter here. From the standpoint of comparison, is this the best way of presenting these graphics perhaps? What would you do differently and why? So they're limited in scale because you're doing faceting. They're all on a common scale here. And because the winter temperatures in Oklahoma City are really low, this has to be wide because they're also really high in the summertime. So you're encompassing the entire variation. But what makes this a little tricky? Is Oklahoma City summer more variable or less variable than Galveston? It's a little hard to tell, isn't it? What would make it easier to tell? Partly if it was bigger, if the points were smaller. What else? If Oklahoma City and Galveston were doing what would make it really easy to see if there's a difference in variability? It would be nice if they were sitting on top of one another. If they were sitting on top of one another, what would you change about your facet? Nope, because you would still have four different things. You would facet by season and lay the populations on top of one another. Now you couldn't just stop there because that would then give you a bunch of black dots on top of a bunch of black dots with blue line on blue line. So what would you have to do? What would you have to do in here? Yeah, you would have to do something like color equals population. And then what it would do is it would make Oklahoma City one color. It would make Galveston another color. You would also have to add color where? You might have to add it to Geom Smooth. This aesthetics might carry over to Point and Geom Smooth, but it might not. You would just have to, in theory, putting it up here should color everything the same all the way through. But just know that if you get a blue line for Geom Smooth, you also need to tell it color up here. And it might be color or it might be group. Either one should do the job, but experiment with it and it'll give you different colors. And then you would have those two populations sitting on top of one another. You would be able to see which points were which, except that if the points are all solid, you're going to have points laying on top of one another. How can you make those points so that you can see through them, so that you can see the other population's points at the same time that you see the first population's points? Making points transparent. So if you put this on top of that, you're going to have some points that are sitting on top of one another. So if these are 100% opaque, some of these points may hide these points. How can you make your points transparent?
Is it like that fill percentage?
It's not fill, but it is alpha. So under geom point, you would do alpha. Alpha equals 1 is completely opaque, and so the smaller the fraction, the more transparent they are. And when you get to a level of transparency where you can see clearly all of the data points laid on top of one another, you can stop, essentially.
So you put it population seasons on top of each other.
Yeah, you can. Yeah. So here's another thing. Here's another way that you could graph this. You could actually graph this on a single plot. But when you plot it on a single plot, you could just make this whole plot this thing and do group and never facet it, and it's going to give you this graphic, but because you grouped it by population, it will do the regression here, the regression here, the regression here, and the regression here. And because you're coloring it different colors, each of those regression lines will be a different color.
Do you think the best way to do it is still just to facet it?
No. That's how I would do it. That's not necessarily the best way to do it. That I just described, doing it all on one graphic, and then letting you color and do the regressions by subsetting of the data, that works also. You would have to group not just by population, you would have to group, to do that, you would group by both population and season to get it to group it, but then of course you would have to concatenate that. These are all things that we've played with in the past. So in my experience, I will do an analysis in R, and it will take me about 5 minutes to get the data in, get the data cleaned up, and do the analysis, and then I spend the next 3 hours getting a graphic that I'm happy with. And it's because I've now given you 3 different ways of graphing this particular data set. And if you play with the different kinds of data, faceting, I've given you like 6 different ways of graphing this particular data set. Find a way of graphing the data set that makes sense to you. If it's faceting, that's fine. If it's overlaying all the data on one single graph, that's fine. If it's 4 individual graphs, each one based on a subset of the data, that's fine also. The advantages of single figures versus multiple figures is it allows you to make comparisons across groups easier, and it also means you only have to write one figure caption. That comparison across groups is sometimes important for the person receiving the analysis so that they can make comparisons easier. Just like putting all of the regression summary statistics in a single table makes making comparisons easier. Always, whatever decision you make with making tables, whatever decisions you make with making graphics, your thought should always be, does this graph help the recipient of the analysis understand what the analysis is saying, or does it hinder them? If it hinders them, try something else. Questions? This assignment is due Friday at the end of finals week. There will be a link on the website for you to submit it, just like last time. You need an R Markdown in PDF file and your report in PDF file. I will not be here on Friday. I will be out of town, so we will not have class on Friday. So if you have questions on this over the next couple of days, feel free to email me. I will get back to you via email. And I'm reasonably good at troubleshooting things via email. If you're having troubles after that, I'll be in town on Monday and throughout all of next week. So I'm free to just make an appointment with me and bring your computer by, and we'll see what we can do as far as fixing things. Yeah.
And then as far as like, we still have to test our assumptions.
Yep, you still have to test your assumptions. So use the Shapiro-Wilk test, use the non-constant variance test on the residuals for Shapiro-Wilk test, and then it's just on the model for.
On the model.
Yeah, so you will have 4 different tests of normality, and you will have 4 different non-constant variance tests, one for each subset of the data. Because clearly, because these data are distributed this way, if you do the big model where you don't subset the data in any way at all, you're going to find that this is not normal because you're going to have a big cluster of data here and a big cluster of data here. So this overall data set appears to be bimodal.
Yeah.
So you don't want to do that normality test on the entire data set. You want to do that normality test on the subset of the data that you're working on for that particular regression. So yeah, you're going to be doing everything 4 times. The only thing that you might not be doing 4 times is creating graphs 4 times.
It's the exact same data file as.
It's the exact same data file that you've been working with. When I created that, I created it to be serve double duty for both these tasks. You have course evaluations. Please fill them out. I'm also going to send you a course-specific evaluation that deals with what the learning goals were with this particular course that you'll fill out. It's a type into Word kind of thing. Do that, and I will reward you for doing that in terms of adding 20 points to your total point total for the course, which will then not be averaged. It'll just be an addition. So
That's for the idea survey.
I know, because I have no idea who does the idea survey, so I can't award points for doing the idea survey. Although the more people who do the idea survey, the happier the people in Curry Hall are.
This is the course specific one.
This is a course specific one. What it does, it goes through each of the learning goals for the course. It kind of asks you, where were you at the beginning of the semester? Where are you now? What things did we do in class that helped you make progress on that learning goal? What things could have been done better that would help you with that learning goal? So for me, the course-specific evaluation is really useful for me as I think about what I'm going to do in future iterations of this course or a course like this. Much more useful than the idea survey is, because the idea survey doesn't have any idea that this is a applied stats class. All right, questions? If you finish your report earlier, you can always get it to me earlier. I don't know what your final schedule is like, so work with your own workload and everything else. I could have made it due the day of your final, which would be Tuesday, which seems a little unfair since I just assigned it today, so I'm giving you till the end of finals week. That means that my weekend is going to be busy, but I'll get it all done. Questions? All right. Enjoy the rest of your semester. Yeah. What do you got?
So I'm trying to get the multi-plot.
Okay, so I haven't used multi-plot. So you actually have to have multi-plot. Oh, you did that multi-plot. Da, 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 da. So look up go and search multi-plot in your web browser. Multi-plot, ggplot. And it'll remind us what the syntax is.
Okay.
Yeah, go there. Cookbook for R. I have that book actually. It's very good. So let's see. Da, 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 da. So those are generating plots. Oh, calls to. That's the reason. Okay, so go back to this. Go back to your R thing. Instead of 2, it's calls equals 2. All right, now try that.
That was right.
So you need to run that. Yep. What happened?
Well, I ran the
Oh, go back to this. Oh, no quotes. No quotes on your different graph subsets? Yes, sir.
Just because of my schedule, I'm going to be one of those that's going to have to turn it in a little early.
That's fine.
So will there be a Moodle Dropbox or just email it to you?
I'll try and get it set up today, and then it'll just be sitting there waiting for you. All right. Sure. There, multi-plot. So did you run all these graphs?
Oh, wait. I spelled one of them wrong.
Did you run them?
Yeah.
Oh, you spelled one of them wrong. There it goes.
Awesome.
Now see, the difference between this and doing faceting will just have this thing at the bottom. So all your
Okay.
graphs will be bigger, and it will only have this thing at one side.
Oh, okay.
And so one of the other things that faceting does, it makes all of your graphs bigger. And the other thing is what we talked about, what Blaine mentioned. Notice how your x-axis and your y-axis is different on each of these.
Mm-hmm.
So it makes it almost impossible to compare these
Yeah.
to one another because they're all on different scales.
Okay.
And the other thing is, you don't know what this one is.
Yeah.
Is this winter Galveston? Is it summer Galveston? Is it summer Oklahoma City, et cetera, et cetera? So there's also no labeling. So you would have to go through and change all of these graphs to have graph titles, and then that would put the graph title above the graphic, which would even take up more space and make the graphic even smaller. For all of these reasons, this is why I like faceting, is because
I wasn't able to get the fastening to work, so
Okay.
that's why I kind of
Okay.
just
So go
gave up on
back.
it.
Go back to this. Go down to. So you did. Oh, so run this and show me what this looks like. Okay. So Geom Smooth, you need method in here. So you need to recreate all of this down here.
Oh,
That's fine. Not a big deal. So now it says nice straight line.
yeah.
But what you see is you see winter Oklahoma, winter Galveston, and both summer populations here. So you need to pull that apart. So facet grid. Oh, because you didn't. You're just copying stuff directly off. So, do you have a variable called pop in your?
No, I didn't know what mine was called. I thought it was called population.
Okay, so just do right here. Do head and your data file. Remind yourself of what the. Do it. Run it. Remind yourself. It should be population. Okay, so just do population rather than pop. Now try it. Season not found. You have season. Oh, that's weird.
Yeah. Well, and I tried it with population too, and it said the same exact thing.
Okay. So there's also help here. Oh. Facet grid. So let's go down to the bottom and look at some examples. That's just weird. So you run that. It gives you that. Whoa! Did you make a new data frame that
Yes,
was?
but I might have
What did you?
erased my DAT one whenever I.
Okay, so where did you do that? Okay, so where did you do that subsetting? So first thing you have to do is
I think I just changed my SG, or from my DAT one to the SG after I made it.
oh so we'll filter it so that it gets rid of all those other temperature types. So now when we go down here, let's do this graph here just on that one, okay? Now we shouldn't get any, so now nothing is ignored. So now let's see. Why is it still? What's wrong with my syntax? Oh,
Yeah, I think that's good.
there's a tilde. Once again, I sometimes forget. Ah, there it is. So you have to ask yourself whether you want to facet by population and season or season and population. And you also have to ask yourself whether you want to facet by just seasons or just populations, et cetera, et cetera. But the nice thing about it is you only list your temperature once.
Yeah.
You only list temperature once. Everything is labeled.
Yeah, that
And
is better.
and it's all in common scale. So that's why I like faceting.
Okay.
And now that we figured out what we were doing wrong with the syntax, it's easier now.
I did something, I think I messed up, because I went to facet it, and
Mhm.
then, I think, I don't know, is that the wrong way to do it, is put the naming variable to it when I went to facet it?
Well, you have to give it.
So I already ran this up here.
So you have to give it that thing plus that. So you're not telling it to facet anything.
Okay, I'm not.
So you have to do TV versus TW plus facet.
Just like that?
Nope.
Or would it be like up above? Would it be like
Yeah,
this?
yeah. So nope.
And then you delete
Yeah, you could
this,
certainly do it that way also.
and then just put it plus, return.
You don't need to return even. Yeah. Oh, so back up.
Yeah.
Yep. There you go.
And then we'll
Yeah.
just,
So now run this and run that, and that should give you a faceted graph. Boom.